Hi, my name is Merlin. So today I'm gonna talk about what I learned today. So, but here's the thing. I'm trying to explain. I'm gonna explain how we increase web performance down to top approach, and this is the blog I wrote. So let's see. I think to enhance the web performance, it is really essential to understand three foundational OS concepts. Why? Because as a front-end developer, our primary business target is the user who accesses the internet via Chrome application or Safari application, right? And this application is basically is it just when user clicks it, it just became a program. And what is a program? Program is actually a sequence of instructions, and when program runs, an instance of that is called process. And we have to understand what is process um, because our browser renders is on the render process, and your navigation is part of the browser process, and we really have to understand what is process because our we are front-end developer, right? So we have to understand the background of it. So what is browser actually? So browser is software application, and as you also know, and so application is computer program to design to execute specific tasks for the user. And task sounds really really kind of fancy term, right? But task is we can define the task. User navigates the website, user enter URL, user type the URL, and this is also task. And task is made by process and thread. And what is process and thread? And process, what I talk about the process. Process is just uh, the instance of what program runs. This sounds so trying to elaborate the process, you have to understand what is the model of the process. So process model is defined by two. So what are those? Actually, a resource grouping and the execution. So resource grouping, I mean, talk about the I thought it was address space or some kind of memory thing about, because when process happens, always gives memory to execute. So that's called the resource, and I think there's more about this. uh, so and process can communicate to each other, and which is IPC. And the more interesting part is I talk about the execution part, right? Process is defined process model is basically resource grouping and the execution. And interesting part is the process has a list of thread, and thread one who I believe one who executes it. And the more more the thing you have to aware is difference between process and thread. A process is resource of units of resource management, not a thread. So if each thread has their own address space, open file, pending alarm, so on, so it could be separate process. So thread is just and so you're the you heard about multi-thread application, right? So basically the multi-thread application is just like there are lots of thread in one process, and the process actually cannot share their own address space or others resource, because process is independent. And why process is independent? And because there's kind of part of how the computer science is designed. And there's also security issues, and and there's security issue if we share everything in the process. There could be security issue. And the others, how will you gonna manage the resources if the process are combined? So that's kind of the design of the process. It just they're independent from the other process, but they can communicate via IPC, inter-process communication. And how about thread? So thread cannot. So if thread has another there's a three thread example, three thread in one process. And the interesting part is that I talk about the process have resources, right? And the three thread can share the resources, because thread is part of process. The thread does not have resources, but it just can manage, not manage, it just they can point it. So one thread has a stack, and this is the reason why JavaScript has only one stack, because it is single threaded. But why JavaScript is single threaded? This is part because I'm gonna talk about this, but the summary is answer is because what JavaScript executes the environment is just the single thread. That is why JavaScript is called a single thread. JavaScript itself is not single thread. JavaScript environment is single thread. So that is why JavaScript is called a single thread. So let's back again. So let's assume you want to go to my website, Scriptmind, and to achieve this you have to click Chrome application. It's gonna open application and it's become program. So OS is instruct to open program, right? So in compared to process and browser is not pushed into the process mechanism. Speed scheduling. Why CPU scheduling? It just schedules. It's kind of fancy term. It just schedules the process. Like you are schedule. There's a example. You have a lot of schedule of like work, so you have to schedule it, right? So OS is kind of thing about this thing, and speed scheduling one who schedules, and the process is allows one process to use CPU while the execution of other process is waiting state. So the browser program is converting the process. It is obviously handled by kernel by user level for further computing and execution. Kernel checks requirements demanded by a process and allow them to execution if they are available. When resources are available, process resumes execution until it's completed. So this is a process state diagram. And when I talk about the web performance, it's kind of abstract concept, because example, I have older computer compared to yours. We're gonna look at the CPU processing perspective, because there's like CPU core. So CPU core is just like how many process it can do at one time. So like 3 or 4 or 5, and it just based, so the specs and based on the cores, the version of not version the so if your chip is expensive, that might be example. I'm gonna give you an example of it. Ryzen 7 have like 8 cores, so that means that you can run a lot of 16 threads in one time. So that's kind of benefit of it. But if you're Ryzen 3, so there's gonna be slower than Ryzen 7 in terms of processing the thing. So, but why? But why your website is affecting of it? I talk about this because your website is part of your browser application. The user using our website via clicking application, which is Chrome or Safari. So each browser tab is actually a separate process. That is why other website cannot give bad or good effect on the other website, because each tab is separated, the process separated. If process separated, it means that independent, they are not sharing the same resources. So that is why we have to make the process independent, or else our website is gonna be shared, and my website could give bad impact on your website, and that's why why process is kind of independent. And now so the web page render is also a separate process. So numerous processes are executing, and if it is for a single task, and we have to consider OS part. No, as a fourth developer, we don't have to consider the OS part of it that much. But understanding this, we're gonna help you, I believe, because what we're gonna talk about is also browser architecture. So how browser is built using process and thread so let's see. I talk about this browser the process that can communicate via IPC. So in the browser process, there are UI thread or network thread and storage thread, and but there's more of it. In the browser process, there's a network process and UI process, storage process, GPU process, and something like that. So so sorry, browser process and their utility process, GPU process, plugin process, and render process. So which process controls what? So this is a table. So browser process handles like address bar, bookmark, and backforward buttons, and network part, and render process controls anything inside the tab where website is displayed, and plugins like this, GPUs like this. Yeah, I don't wanna talk. I don't wanna like read this. So each tab is separate process. So and the web page's render is also separate process, and numerous processes are executing. And one important aspect we haven't covered yet is flow of the website navigation. So so this explanation of navigation could explain how the browser is doing it in terms of process or thread. So at the navigation part, you're searching it. So you open Chrome and you're typing on the address bar. And the thing is that there is as you can see in that image, there's like recommendation, right? So it recommendation, and you have to know that UI thread is doing it. So what doing what? Just uh, it just check it just check it is if user is finding just finding just a keyword or the URL. If it is URL, if each user clicks it, it's gonna be navigation. So that's navigation starts. So so what will happen? So of course the address bar uh will be changed into round thing, because I mean the round thing into X. So the UI is changes. So to clarify, user thread initiate the network request. So it just like it actually delegates this task to another thread. So that's called network thread. So we have to we have to know that we're physically not going to the website that we request. We are getting it. We are getting data of it. We are fetching the HTML of the page, which is the foundational part of the website. And however, so the reason we are fetching HTML is on so only becomes clear clear if when you deploy into a static web server, where the HTML provides a XML framework that the browser needs to render the page. So let's say Nginx, HTTP web server, the Kaspersky, and other else, but we are using a web server, static web server. So if you can see in your configuration part, so we are actually putting the HTML on some kind of location, and that means that our actually this route, this URL is just the HTML. We can type that HTML. Yeah, that's the interesting part, right? So we are actually getting HTML resource. And it is really important because we are getting the resources. So if the website server is really far from yours, so there's gonna be impact of your web performance. So but how the server knows where the website is, actually DNS lookup. So we don't know actually how, because DNS lookups, because at the first time we don't know where is the web server. We have to find the address of the web server and request the HTML, and web server will respond to the HTML, right? But we have to find the web server's address first, and that is how DNS lookup does. So what is DNS? Is domain name system. It's essentially internet address book. It just changed domain name into IP address. So IP address is just like your website address, but in terms of computer's perspective. So DNS resolvers is so DNS domain name is just the abc.com, the name of your name, your website name. IP address. When I talk about this, it's just the location part. It's just the protocol that represent your location in the computer perspective. And so what is DNS resolver? DNS resolver, it just resolves the domain name into IP address. It's just like phone book, just list of key value pair of domain name and your IP address. So when you hit enter like website like abc.com in the browser just check the cache memory if there's like abc.com and the IP address. If it doesn't, it go to the DNS resolver to check it. But if DNS resolver doesn't have it, it goes to root server. But root server that doesn't have the IP address itself, but instead it just goes to the top level domain name system. For example, if it's abc.com, abc.net, abc. Some kind of I don't know what else. So if it's .com and it goes to the TLD top level domain system, top level domain, which has the .com and .net etc and blah blah, and so and when TLD server directs to request, get a request, it redirect to the authoritative name server that holds DNS record for the abc.com. So it just like find a link of the DNS lookup process. So after getting it, it retrieves DNS resolver, right? So DNS resolver then cache into it, and then it sends to browser and cache it and browser now and goes as to the web server to fetch the real HTML, and this process is called the DNS lookup. So, but the thing is that when it comes to web form, improve DNS lookup times can improve your web performance. Example, Netflix optimized their DNS infrastructure by owning their TLD Netflix. So by using it, you can just you can, rather than, because there .com.net, there's a lot of URL that has .com.net, but the TLDs, but .netflix, there's only little of it because Netflix owns it. So there could be a slight of, not slight, but there could be some kind of web performance is kind of fast. It's and kind of then it's kind of fast than .com.net, but you cannot own your TLD in it's not realistic if you're a big tech and you can own it, but if you're not, you cannot. But owning that, you can enhance the web performance. Yes. So but we don't have budget, so we're not gonna buy the TLD. It's impossible. So now, but so that's the how we optimize web performance before website even renders. But now we're gonna talk about the what how to optimize web performance when it renders. But this is actually end of today. So we'll just look at the part of before it renders. I'm gonna talk about the after it renders tomorrow. Okay, see ya.